Good day to all of you. Today we shall discuss on data structure part 2. In this we'll discuss the different types of data structure in detail. So what is data structure? It is a way of organizing the data in computer memory. What is its aim? Its aim is to reduce the time and space consumed by a program. In the classification of different data structures, we can see that they can be broadly classified in two types: linear data structures and non-linear data structures. So under linear, again different types: static or dynamic. In a static data structure, we have array type. In dynamic data structures, we have queues, stacks, linked list. Under non-linear, we have trees, graphs. Okay. So again in this type we can see the different types. Arrays are homogeneous kind of data structure. Means they will be storing similar type of data. And the data structures which hold different types of data, that is structure. So structures are heterogeneous kind of data structures. Okay. Hence we can say that the data structures can be either linear or non-linear, static or dynamic, homogeneous or non-homogeneous. Okay. So static data structures means they will be of fixed size. Dynamic data structures means their size can vary. So arrays are the best example for static data structures. Linked list for dynamic data structures. In homogeneous data structures, they store elements of same data type. For example, array. In a non-homogeneous, we have structures. In linear data structures, elements will be stored in linear sequence, and in non-linear, they will be not stored in linear sequence, like in a tree or graph data structures. Arrays, linked list, queues, they are the example for linear data structures. So this is all about the different types of data structures. So next we shall see this one by one in detail. So the first one is arrays data structure. Okay, this is linear kind of data structure, this is static kind of data structure, then homogeneous kind of data structure. So in one line we can say it is a linear, static, homogeneous kind of data structure. Once if it is size declared, it will be fixed. We cannot change it. That is what is the meaning of static. Homogeneous means similar kind of elements it can store. And linear means elements will be stored in sequential manner. So in contiguous memory locations. So this diagram shows array data structure. Its name is value. How many values are stored here? 7, 11, 6, 55, 98, 45, 16, 96 and 46. These are the values or the data that are stored. How many? 3, 5, 7, 9 values are stored. So in 9 consecutive memory locations, one by one, a value is stored. Whole group is called as value array. The name of array is value. Then what about this? This is index of memory location. Means in first memory location, its index is 0. So value of 0, that memory location consists of 7. Value of 1 means a memory location whose index is 1, in that 11 is stored. Then index is 2 means in value array in index 2 memory location 6 is stored. Suppose if you want to access this value, then how it is referenced or accessed? Value of 4 means in index 4 that memory location 98 is stored. Okay. So lower bound of index is 0. The upper bound is 8 here. 0 to 8 means totally 9 values are stored. That is what the meaning. So if you take up this Example, it is an initialization statement in a C program. If you consider array is ARR, how many elements are there? 5. That will fix 5 consecutive memory locations. They are reserved. So in first memory location whose index is 0, their value 2 is stored. In index 1 memory location 4 is stored, and so on. So this figure shows how this ARR array is stored, whose size is 5. ARR is the name of array. In index 0 memory location 2 is stored. In index 1 memory location 4 is stored. So in index 2 memory location 8, 3 index location 12, and the last index, that is 4, in that memory location 16. So array lower value is 0. It always starts from 0 only. This higher value depends on size of the array. Because size of the array here it is 5, the last memory location index is 4. So 0 to 4 means 5 memory locations are there. Since it is array, these 5 locations are consecutive memory locations. Okay, so that is what is array. Next, array can be used to store the scores of a group of students. So what are the applications of arrays? For example, suppose marks of group of students are to be stored. 10 students are there, 10 maths marks are to be stored. Given some name in memory, 10 memory locations will be reserved when array declaration is done. In those 10 memory locations, because these are related values, maths marks, they can be stored one by one. So the temperatures recorded by weather station, sorting and searching, implementing stacks, queues, trees and graphs in dynamic programming. So arrays are stored. In real-time applications means in signal processing, multimedia applications, robotics, real-time monitoring and controlling systems, financial analysis, scientific computing, arrays are used. So the next data structure is linked list data structure. So it is also linear data structure, but like arrays, it is not stored in contiguous memory locations. Wherever elements are stored, they are linked through pointers, hence they will be in sequential manner. Okay, so the data which are stored, they are called as nodes. Along with data, the links will be stored. If this is the data, along with that link will be stored to which next data it will point to. And here this link will store the address of next data. Hence, whole thing forms a sequential data structure. But A, B, C data, they are not in contiguous memory locations. Wherever they are stored, they are linked with the pointers. So the examples for applications, images are linked with each other. That is done through linked list. Image viewer software uses linked list to view the previous and next images using the previous and next buttons. Means these previous and next buttons will be using the pointers associated with each data in the nodes. Web pages can be accessed using previous and next URL links, which are linked using linked list. Music players also use the same technique to switch between music. So the next, stack data structure. Stack data structure is also linear data structure, but it follows particular order in which operations are performed. So to implement stack, arrays are used. So it can be called as LIFO or FIFO data structure, last in first out or first in last out. In stack, all insertion and deletion are permitted at only one end of the list. Okay, so this is the first in, that can be taken out only when this is taken out and this is taken out. Okay, the last one put was C, hence it will be taken first. So next B, and after that A which was put into the data structure first. Okay. So storing the element into stack, that is push operation. So removing the element from stack, that is called as pop operation. So what are the different stack operations? Push. When this operation is performed, an element is inserted into the stack. When pop operation is performed, element is removed from stack. Top function will always give the last inserted element from the stack, which will be at the top. Without removing that, it will return that data. Size of, it will give the size of stack, that is the total number of elements present in the stack. Is empty. This operation indicates whether stack is empty or not. So what are the applications of stack in data? They are used in expression evaluation and conversion, backtracking, function call. Function call means when a program is being executed, another subprogram is called which can do a subtask. After doing that, it has to return back to the main program. Then to where it had left, so to come back there, first that address will be stored in stack. So that stack helps to retrieve back the address in main program from where the processor has to resume the operation. Then in parenthesis checking, string reversal, syntax parsing, memory management. So these are the various applications of stack operation. So next, queue data structure. So queue is also a linear data structure. It follows the first in first out principle. Okay. So always elements are added at the end. They are taken from another end, that is called as front end. So this is first in first out. That is also implemented using array. So which was put into data structure first, that will be taken out first. That is FIFO data structure. What are the different operations that we can do with queue data structure? NQ means insert an element to the rear end of the queue. DQ or delete removes and returns the element from front end of the queue. Peek, so from front end what element is there, it will return that value but it will not remove that value. Is empty, it checks whether queue is empty. Is full means it is used to check whether queue is full. So queues are commonly used in various algorithms and applications because they are very simple and efficient in managing data flow. So queues are used in operating systems for task scheduling, data transfer in network communication, simulation of real-world systems like waiting lines, priority queues for event processing. So next, tree data structure. So this is nonlinear data structure. This allows quicker and easier access to the data. Okay. It is hierarchical data structure. Means it stores the information or data in the form of hierarchy. If you observe this figure, which is showing a small part of Unix file system hierarchy. File system hierarchy means the directory, subdirectory, in those subdirectories which all files are stored. So this information is stored at different levels. First, we have to see to directory. In that which subdirectory we can get the required file. So storing the data at different levels, that is called as hierarchical data structure. This is not a sequential kind of data structure. So this belongs to nonlinear data structure. Okay. So apart from Unix file system, which is an example for tree kind of data structure, another one is web page. So this is the code for web page. Web pages are created using hypertext markup language, that is HTML. That is HTML here. That starts and that ends here, that code. But inside that, what all is there? Whatever heading is required, that tag is used here, head and end of head. In this metadata information, then title. So in head, metadata information and title. At the same level of head, we have body of the HTML, content of the page. So at the same level of head, we have body of the page. So in that, we have here second level of headings. So they will be smaller than the title. Okay. So here this is h1 tag, right? H1 tag is ended here. So a simple web page, that will become the header 1. So here then under that we have mentioning hyperlink, that is a end of a, that is hyperlink, means the content of web page, that how it is created using tags, in which level they are to be written. So that is a data structure. Okay. So to which data structure it belongs to? Tree data structure. At different hierarchical levels, the data is stored. This is the second example for tree data structure. So what are the basic operations that we can do with tree data structure? We can do search operation, searching for a particular data, whether it is present, yes or no. Then traversal means traversal deals with searching every node in the data structure, one at a time, exactly once. So this is used to check the node data or update the data. Okay. Insertion. There are multiple ways to insert an element depending on the location, like inserting element in rightmost or leftmost vacant position, or inserting the element in first empty position available. So insertion is another operation that is done on tree data structure. Then there are different orders of traversals are there. They will give the data. Nodes means data here. They will give the data in sorted manner. Okay. Next, graph data structure. So for graph data structure, best example is Facebook. Then what is graph? Graph will be having nodes. So these nodes. So actually they are data values. The relationship between data values, this node and this node, what is the relation between those two data? Likewise, the relationships between different data, they are indicated by the edges. Okay. Here data means any user, photos, album, event, group, page, comment, story, video, link, note. The relationship means it is the edge which will be indicating whether the user posted a photo, joined a group, like a page. So whenever new such action is done, new edge will be created between the different types of data here. So that is what is the example for graph data structure. Then which are the graph operations? The most common graph operations are checking if the element is present, yes or no. Then making traversal through graph means visiting every node and only once to check whether the data is yes or no, or to update that data. Okay. Finding the path from one vertex to another means from one data element to another. Adding elements to the graph. So these are various examples of graph operation. The last one we consider hashing in data structure. So what does hashing do? When we give data, a mathematical function is applied to that. Hash keys are generated. Along with hash keys, the given data is also stored. So this is hash table, which stores the given data in the form of a table. Okay. So these are our input data. This is the function employed. So this is the hash key, means in this indexed position in the array, given values are stored. So it is a key value pair. Hashing means generating key value pairs for the given data. Okay, this hash value, this key value that is called as hash value, that is used to store or retrieve the data in hash data structure. So what is the meaning of this? For that, if 7 is the input value, the number of data that is going to be stored is 7, then 7 mod 7 is done, that is 0. So in 0 indexed memory location 7 is stored. Similarly, when 16 is given, because total size is 7 here, 16 mod 7 is done, it will be 2, hence index 2 memory location 16 is stored. Next, if 33 is given, 33 mod 7 is 5, in index 5 memory location 33 is stored. Similarly, 42 mod 7 is 6, so in 6 indexed memory location 42 is stored. So these 0, 2, this 5, 6 are the key values or index values. Okay, so they are also stored, and these actual data values are also, so both together form the hash data structure. So it has key value pairs being stored in the memory for the given data. Example 2, if you consider storing strings A, B, C, D, E, F, G. So hash function chosen here is A, they are treating as 1, B as 2, and so on. AB means 1 plus 2, that is 3. CD means 3 plus 4, that is 7. EFG means 5, 6, 7. When they are added, it is 18. Okay. Hence, in 3 index, AB means 3. In 3 indexed memory location, AB is stored. In 7 indexed memory location, because 7 mod 7 is 0 here, so that is stored in 0 indexed memory location CD. Here 3 mod 7 is 3 only, hence 3 indexed memory location AB was stored. Here C plus D is 7, 7 mod 7 is 0, hence in 0 indexed memory location CD is stored. 18 means 18 mod 7 is 4, so in index 4 memory location EFG is stored. This is how 7 memory locations are used, that the maximum size here chosen is 7, hence that is used for mod operation here. But hash function utilized here, A is treated as 1, B as 2, and so on. So in different applications, different hash functions will be chosen, but storing is always this key value and this data value. Key value pairs will be stored. Okay, that is what is hash data structure or hashing data structure. So the applications of hash tables where key value pairs are stored, they are used in databases, storing and retrieving data based on unique keys. They are used in caching, so whichever data was frequently accessed, so if hashing applied there, it can be retrieved faster. Then in symbol tables, mapping identifiers to their values in programming languages. Okay, these are some of the applications of hash tables. Then application of data structures as a whole. They are used in operating system. The data structures are used in graphics, computer design, blockchain, genetics, image processing, simulation, etc. Data structure is very important, because for a problem solving we have to take up an algorithm. The different components of algorithm are built or they are based on data structures. Proper choice of data structures is very important, because it is going to fix up the time and space complexity of a program. So that completes the whole discussion. I hope you understood. Thank you.